I start off the chem activity number 8 by asking the question, can we really predict the formulas for compounds just by looking at where the elements are that make up the compound in the periodic table? Fortunately, the answer is yes for many compounds, and this is not really an act of memorization. The goal of chem activity number 8 is to guide you on how to use the periodic table in coming up with or predicting the chemical formula and also the name of the compound. The intended learning outcomes are that you will be able to classify compounds into two major classes, ionic and molecular, that you'll be able to describe the ionic bond in terms of an attraction between oppositely charged ions, to determine which cations will be formed from metals in groups 1, 2, 3A of the periodic table, determine which anions will be formed from nonmetals in groups 5, 6, 7A of the periodic table, explain that the charge of a transition metal cannot be predicted and that some transition metals can form more than one ion, but also to know that the silver, cadmium, and zinc cations have single charges. Deduce the formula and state the name of a binary compound formed from elements 1, 2, 3A and 5, 6, 7A. Finally, to predict the formula and give the name for a compound of ternary ionic compounds involving polyatomic ions. Let us get started. Right here I have the model of a periodic table. It's only a portion of the periodic table, and it's just indicating what the charges are for when the elements become charged. I've selected certain representative elements. Now I'll remind you that the elements under atomic state or neutral state, of course, don't have these charges. So these are the charges of the elements when they have lost or gained electrons. Before we begin to look at some of these charges, I want to remind you about some aspects of the periodic table. For instance, the rows are called periods and the columns are called families or groups. I'd like you to be familiar with some of the more common families or groups. We've got 1A and 2A all the way through to 8A. There are all in all 18 columns, but the ones that are indicated by the A are the more common columns. They're called the main group elements. 1A and 2A are the alkali metals and the alkaline earth metals, respectively. And yes, you need to know those names. 7A are the halogens and 8A are the noble gases. You don't need to know the names for 3A through to 6A. We'll just refer to them by their number. Something else I'd like you to notice about the periodic table. A very important aspect is that essentially it's cut into two, although not equally into two. And that's based on the staircase. To the left of the staircase, we have the metals. To the right of the staircase, we have the nonmetals. The elements that are found in and around the staircase are known as the metalloids. I will not specifically ask you to identify the metalloids, but I really do need you to know who are the metals and who are the nonmetals. You will see that remembering this fact, that is, which elements are metals and which elements are nonmetals, will guide you in being able to make a series of predictions, not only for this section of the course, but throughout the course. This is a very important division in the periodic table. So what I ask you to do now is look at the key questions 1 through 4. In key question number 1, one of the things that I really wanted to highlight is that those elements that are found on the left-hand side of the staircase, when they become charged, so in other words, when monoatomic metals become charged, they will have a positive charge. Metals will never be negatively charged. This will be true throughout this course, throughout the winter semester. Please do not write a monoatomic metal with a negative charge. We refer to these positively charged ions as cations. The elements that are found on the right-hand side of the staircase are known as nonmetals. The ions of these elements will be negatively charged. They are also referred to as anions. One of the other things that you were asked to do is to notice the trends. So for instance, besides knowing that the metals will become positively charged, it is also worth noting that the elements that are found in the first column, the alkali metals, will always have a +1 charge. There is some significant underlying theory for why this is true, but at this stage I'm not wanting you to worry about the theory. Rather, I'd like you to notice the trends and patterns you will be able to use in the periodic table to guide you in making predictions. Thus a +1 charge for the alkali metals, +2 charge for the alkaline earth metals. As a result, you should be able to make additional predictions. The key question number 3 asks you to predict what would be the charge, for instance, for the francium cation. And indeed, it would be francium plus 1. Similarly, radon cation would be plus 2. We can also predict the charge, for instance, for phosphorus when it becomes charged, given that it's a nonmetal just found below nitrogen. Phosphorus will have a -3 charge as an anion, and that's known as the phosphide anion. Also, we should be able to predict the charge for selenium as an anion. That would be the selenide with a -2 charge. We can continue to add to the groups of elements whose ions have predictable charges. For instance, when arsenic becomes charged, it will also be -3 because arsenic is found just below phosphorus. This would be called arsenide. And again, in a similar way, tellurium as an anion would be called telluride with a -2 charge. The element hydrogen is one where it's difficult to know where we should put it in the periodic table. We usually put hydrogen just above the alkali metals, and this is because when hydrogen becomes charged, it often will lose an electron, and therefore would have a +1 charge. But this is in compounds where hydrogen is combined with a more electronegative atom. We will say more about electronegativity further in the course, so indeed hydrogen can have a +1 charge. However, if hydrogen is combined with a less electronegative element, such as a metal, it can have a -1 charge. Some periodic tables put hydrogen right in the middle of the periodic table, because it can, in a sense, act as both a positively charged ion and a negatively charged ion when it becomes charged. Other elements to consider are, for instance, gold. This brings us to the transition elements. For now, I'm going to ask you to think of the transition elements as essentially found in the middle part of the periodic table. There is a more accurate definition, but simply referring to them as those elements in the middle of the periodic table is good enough for now. I ask in the key question number 4 whether or not we can predict the charge of a gold cation. Given that the element gold is not found in any of the main group columns, but rather it's found where the transition elements are, the answer is no. This is a key point. We don't know in advance what the charges are for most of the transition elements because they have variable charges. As it turns out, gold cation can be +1 or +3. Additional information has to be provided to you to know what the charge will be. This issue of variable charges applies not only to the transition elements, but to some of the other metals that are found towards the right-hand side of the periodic table. In this context, I'd like you to know that the tin cation can be +2 or +4. The lead cation can be +2 or +4. You will see that additional information is provided in the naming of the compound that tells us exactly what the charge is for these cations. For now, be aware that they can have variable charges. Notice aluminum. Aluminum has a +3 charge as a cation, and that would be as expected based on the fact that it's found in the third column. The element right below aluminum is gallium, and that too we would predict would have a +3 charge as a cation. Therefore, for our purpose, most of the main group elements have ions with predictable charges. Most of the transition elements and some of the other metals like lead and tin have variable charges.